Hello everyone and welcome to my third Arduino tutorial in the Ultimate Arduino Beginner's Guide series. Okay, in this lesson I'm going to teach you how to read analog voltage using a potentiometer. You might be wondering, what's a potentiometer? Well, a potentiometer controls the amount of resistance in a circuit. If it's turned up all the way, I'll talk to you about it in a minute. Right, what you will need: an Arduino or clone, solderless breadboard, jumper wires and a potentiometer. Okay, so that's pretty simple. That's just a small amount of components. Now let's talk about the potentiometer. The potentiometer controls the amount of resistance going in the circuit. If you turn it up all the way, there will be little resistance. If you don't, it will give much resistance. When there's a lot of resistance, there will be 0 volts running through the circuit. When there's a lot of resistance, there will be 5 volts running through the circuit. So that's pretty simple. If you don't understand that, then, well, basically, if you turn it up, it lets all the electricity through. If you don't turn it up, it doesn't. And then how this project will work? Well, there will be 5 volts attached to one side of the potentiometer. Let's say this side. And ground will be attached to the other. The middle pin will be attached to A0, which will read the amount of current on your Arduino. The program will then convert the current reading to voltage, giving us a reading on the serial monitor. Right. What is the serial monitor, you might be wondering? In the top right corner of your Arduino IDE there will be a little magnifying glass, so I'll just do a little sketch for you. So let's say you've got your Arduino, you've got all this bar, and you've got like file and stuff, and then up here you'll have, let's just extend these, you'll have another one that says, it's got a little square and it'll have a little magnifying glass. When you hover over it, it might say serial monitor. You click on that, and it's a way of your Arduino communicating with your computer, basically. Your Arduino will print the amount of voltage going through the circuit onto your serial monitor so that you can read it. Now, you need to wire up your components. This is quite a basic wiring diagram. You need to wire your left pin to ground, which is this one, and you can see it's going to ground. Wire the middle pin to A0 and log in, which is this one here. And then wire the right pin to 5 volts. So I'm going to give you 5 seconds to pause it and get that wiring diagram done on your Arduino. Okay, you should have got that wired now. Now let's have a look at the code. Right. If you don't understand all of this code, then it doesn't massively matter. I'm going to explain it the best way I can. If you don't understand it now, then in future lessons I'm sure you will when we go over it. So, the first thing you do is set the program up using void setup. Void setup only runs once, unlike void loop, which runs forever. So void setup, this runs once. It sets up the program. As in previous lessons, we've looked the 2 brackets facing each other, the opening curly bracket, you write your code, and then a closing curly bracket. Okay, just to recap. Void setup is a function. After a function, you have 2 brackets facing each other, an opening curly bracket, you write your code, and a closing curly bracket. Then here is another example of a single line comment. Okay, initialize serial communication at 9,600 bits per second. You might be wondering, what is the 9,600? To be honest, it doesn't matter. You just need to accept that's what it is. It's just the standard speed. You don't need any more, you don't need any less, you just got to accept it. Serial.begin 9,600. Now, in our previous lesson we looked at pin mode, digital write and delay. This is another piece, serial.begin. Now the serial monitor is a way of your Arduino communicating with your computer. You open the serial monitor and the Arduino will print onto the serial monitor the amount of current running through the circuit. Now you need to tell your Arduino that that's what we're going to be using for serial monitor. Serial.begin. This tells your Arduino that we're using the serial monitor, so get started really. And then 9,600, that's just a standard communication rate with the serial monitor. Okay, now in this next piece of code we're going to have a variable. In this program you're going to create a variable before you get into the main part of the program. Variables are names you give to places in the Arduino's memory so you can keep track of what is happening. These values can change depending on your program's instructions. Variable names should be descriptive of whatever they are storing. For example, a variable named sensor value tells you what it stores, the value of a sensor. So if we have a look at this code here, the loop routine runs over and over again forever. So void loop, you have two brackets facing each other and a opening curly bracket followed by a closing curly bracket. Pretty simple. Now, we are getting a bit more complicated now, so you need to be paying full attention. Int sensor value. Variables are in black, unlike most code, which is all coloured and fancy. You know it's a variable because it's black. Now, we're looking at this part here, int. Int sensor value. If you put int before a value, int stands for integer. Integer means whole number. Integer variables can only store whole numbers. Well, I'm being really poor here. We can only store numbers, okay? Some variables can store words and other things, but integer variables can only store numbers, and it is the main thing that you're going to be using. Integer variables for a lot of Arduino code. Because a lot of Arduino code is about numbers and maths, you know, the actual code and stuff. So, a lot of them are integer variables. Now let's have a look at what it's saying here. Int sensor value equals analog read A0. This is another statement we're looking at. Analog read A0. Our middle pin of the potentiometer is wired to A0. So it's saying the sensor value is equal to the amount of electricity going into A0, which will be controlled by you controlling your potentiometer. Okay, so int sensor value is going to be the same as whatever is running through the same amount of electricity running through your circuit, which is being read by analog read A0. If we go back to the wiring diagram, look, it's connected to A0. So it's reading A0, finding out what is connected to that code, you know. It's finding out how much electricity is running through that pin, and that's what sensor value equals. Okay, the next part. Convert the analog reading, which goes from 0 to 1023, all analog readings goes from 0 to 1023, to a voltage, 0 to 5 volts. Now, this is another thing that we're looking at, float. Float uses maths to convert numbers that the computer understands to numbers that we understand. So if we look at this, 1023 means 5 volts, but if we saw on our serial monitor 1000 voltage equals 1023, we'll be thinking, really? No way, because 1023 volts is ridiculous. It wouldn't be that much. So what we're saying here is 5.0 equals 1023.0. So it's saying when it is at 1023, it is actually 5, and it will display 5. So we said here, float voltage equals sensor value, which is analog read, 5 over 1023. And it's saying that when it's at 5, when it's at 1023, it's at 5. And then, here we've said serial.println voltage. Serial.println prints something to the Arduino, okay? To the serial monitor. So, in this case, it's going to print to the serial monitor the voltage that we've got using this calculation, which will be from anything from 0 volts to 5 volts. And then here we have the finished code. Now, if you don't understand that code, don't worry massively, but I want you to copy it into your Arduino IDE so that we can do some challenges with it. So I'm going to give you I'm going to give you 5 seconds to pause it so you can copy that into your Arduino IDE. You obviously don't copy the comments, just copy the actual code. It's only like 1, 2, 3, 4, 5, 6 lines. Okay, so now you will have the code copied into your Arduino IDE, and I've got 2 challenges here. Challenge 1, change the analog read pin in your Arduino code from A0 to A1 and modify the code. So, in this code we have used A0. It's been reading A0, the middle pin's connected to A0. I want you to change that to A1. And the second challenge is print your own personalised message into the serial monitor. So serial.println. Okay. You can make a new piece of code for that if you want, but remember you have to do void setup serial.begin 9600, and then you can write whatever you want in the loop. And that's it for today. Thanks for watching, and be sure to watch my many other Arduino tutorials. Next time we're going to be looking at turning an LED on with a button, which sounds easy, but it's quite hard, some of the code is. Thanks for watching, and I'll see you next time. And